So one of the other things that we have to consider is not every reaction takes place between things that are either in solution or a mixture of gases. Sometimes we have things where there are solids or liquids involved. So we have what's called heterogeneous equilibria. Everything at this point where we've talked about Kc and Kp have been homogeneous equilibria. Everything is in the same phase, and we're either talking about a mixture of gases or we're talking about things in solution, so mixtures of solution, things that have concentration. So gas and aqueous solution mixtures have concentrations. Pure liquids and pure solids do not have concentrations because they're not mixtures, they're a pure substance. So what that means is, since we base our equilibrium calculation on concentration, pure liquids and pure solids, and this is experimentally observed to be true, do not factor in to where the equilibrium point is. So, for example, if I look at the breakdown of calcium carbonate into calcium oxide, which is lime, and carbon dioxide gas. Well, again, carbon dioxide is a gas. I can measure its pressure. In theory, I'm collecting it not necessarily in a vacuum, so it has a concentration. I mean, even if it isn't a vacuum, it has a certain volume space that it's filling in a certain number of moles. So it has a concentration. It's exerting a certain pressure. It turns out that because the calcium carbonate, the limestone, if you will, is a solid, and one of the two products, the lime, calcium oxide, is also a solid. Neither of those things factor into the equilibrium calculation. The only thing we have to determine or work off of is what's the concentration at equilibrium for the carbon dioxide, or what's the partial pressure. And since there's only one of them, it's a very simple calculation. So whenever you look, and this is why phases are important, gases and aqueous solutions factor into our equilibrium calculation. Pure solids and pure liquids do not.